Hello, my name is Mr. Rogers, and you're watching the video lecture for 2-1 in our book on earthquakes. In this first section, we're really describing what happens that's going to cause the earthquakes and where these are going to happen. So, talking about these fault lines. So our first objective here today, guys, is to be able to describe stress in rock. What causes stress and what different types of stress are there? Our second objective is to describe how faults can change the shape of the earth. How about it? So, brand new unit, guys. We're going to jump right into it here. So, an earthquake, simply put, here's our basic idea of the whole chapter, is the shaking and trembling that results from the movement of crust. So anytime that top layer of the earth, that solid rock, these plates, and we have these fault lines, an earthquake happens, we get that shaking and trembling. And what causes this? What causes earthquakes in the earth here? What's happening is we have stress. Stress is being put on the rock. And that's because these plates, again, are kind of moving, bumping into each other, pulling apart, and that creates this stress. Those plate boundaries and that convection currents in the mantle, that creates that stress on the rock because it wants to move. And so, rock doesn't want to move. And so the stress is building up in the rock. And there's different types of stress we're going to look at. So the types of stress are going to relate to our plate boundaries you'll see here in a minute. So you'll see they look a lot the same because the type of stress you'll see that look just like the type of fault that it creates. So our first type of stress in rock is called shearing. And shearing pushes masses of rock in two different directions. You can see it here in the picture in two opposite directions. This is going to form, if you remember from the last chapter, the transform boundary would be caused by this type of stress. Simple enough. So moving on, our next type is tension. Next type of stress is tension. This pulls on the crust, stretching the rock so it becomes thinner in the middle. So again, think about a divergent plate boundary. This type of stress would cause a divergent plate boundary. It's being pulled apart. On land, we get those rift valleys. Think about when we're pulling that Laffy Taffy apart. On the ocean floor, this is that we get the mid-ocean ridge. Now, our last type there of stress is compression. This is when we squeeze rock together until it folds or breaks. So think about the convergent plate boundaries would be caused by this type of stress on the rock. So it's being pushed together. And depends on what type of crust you have. This could create mountains. It could create those deep ocean trenches. It depends on the type of crust. So those are our three types of stress. That's the first big idea from this chapter. So now using that stress, this is going to create different fault lines. Different fault lines are created by the different types of stress as that rock actually starts to break. So a fault is a break in the Earth's crust where slabs of rock slip past each other. And again, we'll look at three major types of faults we're going to look at, and they're all related to the different types of stress we just talked about. So our first one is a strike-slip fault. A strike-slip fault occurs where rocks on either side of the fault slip past each other in a sideways motion. So a strike-slip fault, that's San Andreas fault line in California. It's also known as a transform plate boundary. You can see the two sides of the fault line. In this case, would also be two sides of the different plates, excuse me. But again, these usually occur along plate boundaries. The major ones do, but there are hundreds and hundreds of minor fault lines across a plate. So some of the major fault lines do occur at the plate boundaries, but not always. There's not plate boundaries. There's fault lines here in northern Illinois. There's very small and not nearly as active as the ones along a major plate boundary like in California. So our next type of fault is I'm going to come back to that picture there, is a normal fault. And a normal fault occurs when a rock is pulled apart at an angle, so one block of rock lies above the fault and the other below the fault. And you can see that here in the picture. So you can see the type of stress. You see the arrows pulling apart, so this is caused by that tension. It's being pulled apart. And what happens is we have our fault line here, that fault plane, they say, just where the break in the crust is. And as it's pulled, one half is kind of being pulled more up, one half is being pulled more down. And so you say the footwall here is known as the footwall. The lower half below the fault is the footwall, and that's moving up. And the hanging wall, you kind of see, you can almost hang something off the edge of the fault line, is moving down. Our third type is a reverse fault. Kind of the opposite thing happens here in a reverse fault. This occurs when rock is pushed together, forcing the hanging wall up. So again, you can see here the type of stress is compressional. It's being pushed together. And there's our fault line. And the hanging wall is moving up this time. That's what's above. This part here is above the fault line. So it's our hanging wall. And here down below, this would be below that fault line, that is the footwall, and it's moving down. It's being pushed down by compression. So those are our three different kind of major type of fault lines we're going to be looking at. And so what can happen? What else can happen because of these faults? We can get something called a fault block mountain. And this occurs when two normal faults uplift a block of rock. So that's just, here's be an example of a mountain range. And as it's being pulled apart, it'd be an example over here too. It's being pulled apart, we get that shearing, this very sheer face of a mountain. The Grand Tetons, kind of a bad picture there. The Grand Tetons in Wyoming are an example of a fault block mountain. Another example are folds, almost like when you just fold a sheet of paper, just push it together. Or when you get a rug and it gets kicked and it gets folds in it. Folds are bends in rock that form when the compression, so you're pushing it together, shorten and thicken part of the crust. So when we get the peaks and valleys really close together, would be those folds in the rock. Alright, so going back real quick, guys, I want to explain one thing. I had this very simple picture here, and here's like the surface of the earth right here. Here is our fault line in green. And how do we know that's there? How do we know there's a fault line there? We kind of just drew a line. And it goes back to a math term, kind of like a scatter plot. And so what scientists did to kind of figure out where these fault lines were, again, we can't see down 10, 20 miles even down under the earth. But we kind of locate these epicenters. I'm sorry, not even epicenter, the focus, like where these earthquakes occur. And so over time, they start developing these patterns of where all these earthquakes have happened. You see all the dots that are on the page here. And over time, you get a pretty good idea of where that fault line is based on where all the earthquakes are happening. So it's going to happen along that fault line. So we kind of get this scatterplot looking smattering of epicenters, not epicenter, I keep saying epicenter, of the focuses or foci. And that helps us determine where the fault line is. And that's how we know on these faults where this fault plane is, which are normally at an angle like this. Okay? Alright, so 8th grade, we're going to stop there. I thank you for watching, and we'll see you along the way.